Hello students, welcome back. Let's see, where were we? We went through this example and we completed problem A. Okay, let's go to the next problem. Part B of the problem. The line running through the point -1, 2 that's parallel to this line. Okay, parallel. Parallel lines share the same slope. So the same slope as this line, what is that slope? Can everybody read it, by the way? Okay, we have some fractions, so a little bit bigger font will be helpful. So what's the slope? 2/3, and then running through this point. Make sense? So y equals to, oh, sorry about that. Y equals to slope m x minus x0 plus y0. That's a slope point equation. Now, slope is 2/3, and then running through x0 comma y0. Right here, -1, and then y0 is 2. There you go. All you have to do is to simplify this. Y equals to 2/3 x plus 1, and y equals 2/3 x plus 2/3 plus 2, but then again 2 is 6/3, isn't it? So put those together, I'm gonna get 8/3. Looks like that's the answer. And this is my solution. A lot of students do it this way, and I like it the best, but some people do it the other way as well. So what about the other way? Okay, begin with let's clear everything. Okay, begin with y equals to mx plus b slope-intercept equation. And then what's the slope? Well, parallel to this, so have to have the same slope. So that is the final form. If we find b, then we're going to be through. How do you do that? Well, running through this point. So x is -1 and y is 2. So we do this. 2 equals to 2/3 81 plus b. And then from here we can solve for b. It's a simple equation to solve. All right, let's go ahead. 2 equals to a -2/3 plus b. And then I can flip over. By the way, 2 is 6/3. So flip it over. -2 plus 6. You're going to get b equals to 8/3. Therefore, we get the equation 2/3 x plus 8/3. This is not my favorite way, but a lot of students do it this way. Me personally, I do it this way. Use slope point equation directly and then break out the parentheses and simplify. But some students just work out the slope-intercept equation, just plug in numbers and solve the equation to find b. And then once you find b, original equation should be like that. This is your b value, 8/3. Either way, it works out. What did I do in my answer key here in this notebook? Yeah, I used the first method. And here is a visualization running through this point, -1, 2, and parallel to this original dotted line. Indeed, this is correct answer. Enough time for one more? Okay, let's do one more. The line running through the point 3, -1 and perpendicular to this line. Perpendicular. the product of two slopes must be -1. So if y equals to mx plus b, then m times this 1/2 should be -1. So from here you can find out what m is. Okay, so what do we have? We have y equals to -2x plus b, all right? And then that's running through the point 3, -1. So -1 equal to -2 times 3 plus b. From here I can find out b. What is b? -1 equals to -6 plus b. So if I flip 6 to the other side, 6 minus 1, that's 5. So am I getting this? Y equals to -2x plus 5. Is that what I'm getting? Yeah, I use slope-intercept equation and determine slope because product of two slope is -1. And then after determining the slope, plug in a number to determine b. This is one way to handle it. That's not my favorite way though. So let's call it solution 2. And this is my favorite way. Y equals m x minus 3 minus 1. That is the slope point equation. Alright? Slope point equation. And then you have to figure out slope, but then again, perpendicular to this. And then you see what is the condition for perpendicularity. The product should be -1. So m2 should be -1 over m1, right? We get the negative reciprocal. Negative reciprocal. So let's use negative reciprocal. So from here, m is negative reciprocal. So 1/2 is the slope, negative of 1/2. So this whole thing is 2, -2, excuse me. X minus 3 minus 1. So I can simplify. Negative, negative, positive, plus 6 minus 1. So we get y equals to -2x plus 5. Again, the same answer as before. No surprise there. So, one way, starting from what you want, slope-intercept equation, and determine m by first equation, perpendicularity, and determine b by plugging in numbers. So you have to solve equation twice. That's one way, and I think majority of students have been doing it this way over the years. My favorite way is to use slope point equation, and going from there, the slope is actually negative reciprocal. And I just wrote negative of 1 over 1/2, but this kind of computation, you can easily do it by mental math, because reciprocal means actually flipping over. So 1/2, nobody writes as 1 over 1/2. Everybody simply writes as like this. And then we go ahead with expansion, and we get final answer. To me, this one is a little bit better, and that's why they did in this answer key as well. And then here's this graphical justification. This point, excuse me, this is a point the line is running through, and this green dotted, that's a given line. And then do you see the blue line is indeed perpendicular? That's negative 2x plus 5 is indeed perpendicular to that. Okay, what else do you have to know about the line? Next concept, average rate of change. Nothing more than slope. Difference of y coordinate over difference of x coordinate. Slope formula, rise over run, something you must be familiar with already. But many people use some different names. And in intermediate algebra or elementary algebra, we used to use slope or rise over run. But in higher level math, people call it average rate of change, and they use this delta notation. That's about it. Okay, a couple of examples here. You can stop the playback and read through. A strain of E. coli known as something is placed into Petri dish at 30 Celsius and allowed to grow. And then we have data table like this. And then plot the ordered pairs and then use the average rate of change to determine whether the function is linear. And if you plot, then the solution will be pretty straightforward, you see. Plot, does it look like linear? To me, it doesn't really look like linear, to tell the truth, does it? And then if you take the average rate of change for, you see each interval 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and do your computation, then you'll get a little bit different slopes each time, I think. Let's see. Oh, here I use technology to get the line of best fit, and does it look okay? There's some deviation. They don't really look perfect to me. As a matter of fact, if you actually calculate rise over run for each interval, as you can see, they're all different. Slope should be the same for line, but they're all different. So it's not linear. As a matter of fact, it turns out it's an exponential model, but that's something we're going to discuss in the latter half of the course. Enough time for the next problem. Stop the playback and read through. What do you think? Heartbeats of healthy individual. And then we have this table. Again, let's plot and find out. So if you actually plot those, that looks like linear. And then how do you check? Well, find out the average rate of change for each interval. Difference of y over difference of x, that is rise over run for each interval. Are they all the same? Oh, by the way, this is through technology. They really look like line. Now, are they all the same? Oh, they're all the same. Not even similar, they're all the same. Rise over run. See, difference of y coordinate over difference of x coordinate. They're all the same. That's the slope. Negative 0.25. They're all the same, so it's a linear model. Basically, we are tracking down slopes. Average rate of change, they may sound intimidating, but don't be intimidating. Just slope computation, nothing more.